fundamentals of casting and solidification. Welcome in our lecture heat transfer in casting, lecture 14. In previous lecture we have gone through our basic assumptions and basic fundamental of the energy equation for the casting. So, I have taken two energy conservations, two type of energy exchange within the element by one type of conduction. So, most of casting manufacturing focus on the conduction, okay. But in some cases like furnace design or melting furnace design or some movement in forging we have to design, some movement is there. In that situation energy exchange due to mass motion also. So, I am taking that care also, maybe we will ignore in the upcoming lecture in this type of terms, but in initial stage I am taking that part also, okay. So, what is first law of thermodynamics is saying? Rate of heat added plus rate of heat generated minus rate of heat removed equal to rate of energy change within the element, okay. So, there are two type of energy transfer, conduction and mass motion. So, we have written the coordinate systems, we have done the what is happening in x direction in due to conduction and y direction. We are not taking third dimension because of it will be very clumsy to see. So, I am just taking in two dimension, we can write the third direction based on the two directions, okay. So, rate of heat added will be in watt, okay, equal to in x direction in for the mass motion in and in, okay. There is a 4 term we are writing for 2D, for 3D 6 term, for 1D 2 terms, okay, one for conduction, one for the mass motion. So, we are writing for 3D. So, what can I write? In will be x into dy dz plus q y double dash dx and dz. Similarly, we can write for third dimension q double dash z dx into dy, isn't it, okay. Plus this is the due to conduction, energy exchange with the due to conduction, okay, plus rho u x direction hx dy dz plus rho v hy dx dz plus rho w dx hz dx into dz due to mass motion, okay. The two contribution we have written for in. What will be out? That is rate of heat removed, that is also in watt, okay. And what will terms will be there? Out in x direction q double dash x plus dx dy dz, in y direction q double dash y plus dy plane in d plus dy into dx into dz. Similarly, here we can write in out for 4 term, there are 4 term for 2D, 6 term for 3D. So, what we can write? Q x plus dx double dash dy dz plus q y plus dy double dash dx into dz plus q z double dash plus dz dx into dy due to conduction. Similarly, we can write for the mass motion contribution rho u h x plus dx dy dz plus rho v h y plus dy dx dz plus rho w h z plus dz dx dz, sorry, dx dy, there is some mistake, dx dy, dx dy due to mass motion. Okay, there was a mistake here. Okay, please note down. Okay, this is in and out. Okay, so out has very complex terms q x plus dx double bar. So you have to split that into a simple form. Okay, like this is we can write using Taylor series. Using Taylor series, we can write down qx double bar plus del y del x qx double bar dx into dy into dz. Next term can be written as q y double bar del y q y double bar into dy dx into dz plus q z double bar del y del z q z double dash dz dx dy. Okay. Similarly, for bottom we can write plus rho u hx plus del y del x hx dx dy dz plus rho v hy plus d hy dy dy dx dz plus rho w hz plus del hz del y dy del dz dx dy, isn't it? This term we can write. Okay. Next term will be E rate of heat generated. If there is some rate of heat generated, like in welding, what happens? We put some source, okay, something like that energy we are giving, sometime kind of thing, then it's come, okay. Otherwise, it will not, you can ignore, like resistant welding kind of thing, okay. Rate of heat generated that is equal to q triple dash dx dy dz, isn't it? That is watt per q triple is watt per meter cube. Okay. So, fourth term is rate of energy change within the element. Fourth term is rate of energy change within element, that is E dot equal to rho du by dt. Internal energy is u is the internal energy, dx dy dz. Of okay, internal energy of system, you can write internal energy of the system. So, equation 1 was saying E dot in plus E dot g minus E dot out equal to E dot, isn't it? So, we have equation 1, we have equation number 2, we have equation number 3, we have equation number 4 and we have equation number 5. Okay. One is saying like this, we have all part 1, 2, E dot in plus E dot g minus E dot out equal to E dot dot. Okay. So, we can write all these terms. Okay. And what is the terms? Q x double dash dy dz plus q y double dash dx dz plus q z double dash dx dy plus rho u hx dx not x dy dz plus rho v hy dx dz plus rho w hz dx dy plus q triple dash dx dy dz minus qx plus del by dx qx dash dx dy dz minus qy bar plus del y dy dx dz minus qz plus dx dy minus rho u hx plus del by del x dx hx dy dz minus rho v hy plus del hy dy dx dz minus rho w hz minus del by del z hz dz dx dy equal to rho du by dt dx dy dz. Interestingly, we can see some terms are cancel out. This term is cancel out by this, similarly this, similarly here, similarly here, similarly here, isn't it? We can cancel out. 12 terms are cancel out. Now remaining term we can write down. And interestingly, we can see what is the in multiplication dx dy dz, 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 and right hand side is also dxy dx into dy into dz. So, we can cancel out all dxy dz, dx into dy into dz terms, volumetric terms can be cancel out, and we can write down equation number 6. We can write down minus del y del x q x double bar minus del y q y double bar minus del y del z q z double bar minus rho u del y del x h x minus rho v del h y del y minus del y del z rho w h z plus q triple dash equal to rho del u by del t. We can write down. As we know, h bar equal to u plus p by rho. We can write down dh equal to, isn't it? We can write down. Okay. So, what is left hand side? Minus del by del x q x double bar minus del y q y double bar minus del y del z plus q triple dash equal to rho dh by dt plus u dh by dx v dh by dy plus w dh by dz. We can write down, isn't it? And dh equal to cp dt we can write. Okay. Now, and what is qx? Minus k del t x by del x q y bar minus k del t by del y q z bar minus del t by del z, isn't it? Okay. Equation number 7, we can write down del y del x k del t by del x plus del y k del t by del y plus del y del z k del t by del z equal to rho Cp dt by dt plus u del t by del x plus v del t by del y. Okay. We have removed one term plus here in left hand side. Okay. Now, we can write down assumptions. For this, we have taken some assumptions. In pressure constant, we are assuming assumed pressure is constant, rho constant, material is moving with constant velocity in x, y, z direction. Okay. So, uniform flow. Okay. So, these are the basic assumptions we have taken to solve this. Now, if properties are constant like k, so what can we write? K can be written as rho Cp okay. So, these are the terms we can write here. Okay. Now, we will take constant here del t by del x square plus k. K is taken as a constant and divided by left hand side and right hand side. So, what we can write? Okay, and that is known as thermal conductivity. Is K density rho specific heat Cp thermal diffusion, then all G Vt equal to K divided by rho Cp. The unit is in diffusivity, all kind of diffusivity like mass diffusivity, momentum diffusivity or thermal diffusivity. All three have unit in meter square per second. Okay, it is very interesting number. Okay, so thermal diffusivity is noted by alpha, and that is equal to k by rho Cp, k by rho Cp. So, what will the equation 8? 8 will look like del square T divided by del x square plus del square T del y by a square plus del square T del z square plus q triple dash by k okay. We can write like this. Let us assume q triple dash is 0, no heat generation. Then if no velocity u v, then isn't it, t is a function of x, y, z, that is why we are writing partial differentiation equation in form of partial differentiation equation. Let us assume a steady state. So, isn't it? So, new form will written as del square T del x square plus del square T del y square plus del square T del z square, isn't it? Laplace equation we know, isn't it? Okay. Now, someone saying one dimension, 1D transient equation, what is saying only one dimension. So, and transient term is saying, so we can write like this, 2 dimension del t square by del x square plus del t square by del y square equal to 1 by alpha del t by del t. We are going to use this equation very frequently in our discussions. So, these all equations are in Cartesian coordinate, okay. It is written in the Cartesian coordinate, not in polar coordinates, okay, like spherical and cylindrical coordinates. So, now I am going to write this equation in different coordinate also, okay. In cylindrical coordinate, equation can be written as 1 by r del by del r del t by del r plus 1 by r square del square t del phi square plus del square t del z square, isn't it? We are going to use such equation in our discussion. So, I am keeping that, okay, plus okay, del t by del t plus V r del t by del r plus V phi r del t by del phi plus V z del t by del z, okay. So, this is the equation for our cylindrical coordinate, okay. in a spherical coordinate, let us assume we are no velocity. If no velocity in cylindrical coordinate, then 1 by r del by del r r del t by del r 1 by r square del square t del phi square plus del square t del z square plus q triple dash divided by k equal to 1 by alpha del t by del t. Simple form. Okay. In a spherical coordinate, it can be written as 1 by r square del by del r square del t by del r plus r square sin square theta 1 by del square t del phi square plus 1 by r square sin theta del by del theta sin theta del t by del theta plus q triple dash by k equal to 1 by alpha del t by dt plus Vr del t by del r plus V phi sin theta into r, or r sin theta you can write, r sin theta del t by del phi plus V theta by r del t by del. Okay. This is the our spherical coordinate system. Thank you.